Discussing about the harmonic oscillations. Harmonic oscillations are the oscillations which can be expressed in terms of a harmonic function. We have got two harmonic functions in trigonometry, that is sine and cosine. Because the sine and cosine both have a period of 2 pi. That means after an angle of 360 degrees, the sine and the cosine functions repeat themselves. As you may be knowing that the maximum value of cos of any angle or sine of any angle is 1 and the minimum value of cos of any angle or sine of any angle is minus 1. That means all the cosines and sines of the angles lie in between minus 1 to 0 to 1. That means the sines and cosines of the angles repeat their values after a period of 2 pi. The oscillation which is of constant amplitude and a single frequency is called as simple harmonic oscillation. If we take the case of sine, the waveform of the sine is like this. Why is it so? We will get into the details. This is angle 0, this is angle pi by 2, this is angle pi, this is angle 3 pi by 4, and this is angle 2 pi. Here we can see that if it is the time and it is the displacement, here the value is 0, here the value is 1, here the value is 0, here the value is minus 1, here the value is 0. So it goes from 0 to 1 to 0 to minus 1 to 0. That means it repeats itself after a fixed interval of time or after an angle of 2 pi. The sine function starts from the 0 value as sine 0 is equal to 0. So we can say that y is equal to a sine of omega t, where a is the amplitude, omega is the angular frequency, omega is equal to 2 pi into nu or 2 pi divided by t. We can say that y is equal to a sine of 2 pi divided by t into t. It is a simple harmonic function. Talking of the cos, the waveform of the cos is like this. Here it is y, if it is t time. Here the value is 1, then it is 0, then it is minus 1, then it is 0, and then it is 1. If we take the angles, here the angle is 0, here it is 90 degrees, here it is 180 degrees, here it is 270 degrees, here it is 360 degrees. Now the difference between the waveform of the sine and the cosine is it starts from the 0 value, it starts from the maximum value. In case of oscillations, remember this. In case of oscillations, when the oscillations start from mean position, we express those in the form of sine. If the oscillations start from extreme position, we express those in the form of cosine. That is the difference between the sine and the cosine. Both represent simple harmonic oscillations. Both are the harmonic functions, but the cos is used when the motion starts from the extreme position and the sine is used when the motion starts from the mean position. We can show in the form of cos y is equal to a cos of omega t. Similarly, omega is equal to 2 pi nu or 2 pi divided by t. So y is equal to a cos of 2 pi by capital T into small t, where this t is the time period after which it repeats itself. That time period is t, and t is any time in between 0 to t. Non-harmonic oscillations are those oscillations which can't be expressed in terms of a single harmonic function. Those can be expressed in terms of two or more than two harmonic functions. Like if y is equal to a sine of omega t plus b sine of 2 omega t. This is expressed in form of two harmonic functions. So this is a non-harmonic oscillation. The waveform is like this. This is a non-harmonic oscillation. Let us discuss about the important definitions related to the periodic motion. Number 1 is time period. The time period is the time interval after which the motion repeats itself. we have taken two waveforms, one with the black and another with the blue. Here we can say that the black has got a time period of this t, because the black starts its motion from here to here to here. It completes one cycle in t, so t is the time period of its motion. Now if we take this waveform completes one full cycle in a half time. That means its period is t dash. We can see that t dash is equal to t divided by 2. The time period of this waveform is half of the time period of this waveform. That means this completes its cycle or one period in t, and this waveform completes its cycle in t dash. The SI unit of time period is seconds. It may be represented in days, it may be represented in years also. Okay, now frequency. Frequency is defined as number of cycles per second, and it is given as nu is equal to 1 by t. So we can say that in this time period it completes one cycle. In that time period this waveform completes two cycles. If the frequency of this waveform is nu, as it completes double the cycles, its frequency is 2 nu. So the frequency is the number of cycles per second. The SI unit of the frequency is hertz, and it is equal to 1 upon t. Now angular frequency. Angular frequency is denoted by omega, and omega is the product of the frequency and 2 pi. Omega is given as 2 pi into nu, also be stated as nu is equal to 1 upon t, so omega is 2 pi divided by t. As 2 pi is the angle, it is denoted in radians and it is denoted in seconds. The SI unit of omega is radians per second. The displacement in general is the name given to a physical quantity that is in consideration to change with respect to the time. The displacements can be of different types in different cases. For example, when we talk of a loaded spring with a mass attached, when this mass is pulled or pushed, the displacement is equal to the change in the length of the spring. When we talk of a simple pendulum, the displacement is the angle by which it has shifted from mean position to extreme position. So this is angular displacement. When we talk of sound waves, the displacement is the change in the pressure of the medium when the sound is traveling. When we talk of electromagnetic waves, in electromagnetic waves the displacement is the change in the intensity of the electric and magnetic fields. So in general we can say that the displacement is name given to quantity which is undergoing a change with respect to the time. The displacement is generally shown by y. Y is equal to A sine of omega t, or y is equal to B sine of omega t, or y is equal to A cos of omega t. This y is the displacement as this y changes with respect to the time. This A, B and this A, it is also the displacement, but is the maximum displacement. It is the maximum displacement, and that maximum displacement is called as the amplitude. Thank you.